All right, good morning. This is the Cosmology discussion group for March 9th. My name is Harry Ricker. Vladimir is going to give a presentation on cosmic bubbles in relation to his world universe cosmology. So go ahead.
Thank you so much for introduction. This presentation is inspired by the articles Holeilana, an individual baryon acoustic oscillation, published by Tully et al. In 2023. Authors claim evidence is presented here for the discovery of a remarkably strong individual contribution to the baryon acoustic oscillation signal at Z0.068, an entity that is given the name Holeilana. Beautiful name. Dawson, co-spokesperson for dark energy spectroscopic astronomy, is more inclined to believe that this latest finding is something of coincidence, a chance alignment that simply looks like a sphere with a radius around what you expected for a bound. Man at the antical Holeilana, a billion light-year wide bubble of galaxies, astound astronomers, wrote, according to theoretical predictions, that formation is not quite the right size to be a bowl. This discrepancy could either imply that conditions in the early universe were not quite what astronomers have expected, or that the structure is a chance alignment of galaxies misguiding as a bowl. Let me tell you, truly, he's a great astronomer. He even discovered this Laniakea supercluster, that it was up to date one of the largest supercluster. But unfortunately, he is orthodox, and he is trying always to explain his discoveries and results in frames of Big Bang model, even in case when it doesn't work even. This is exactly the point. Even the other orthodoxies don't agree with his conclusion. Below, we provide a short summary of experimental observations of Guterres void and superclusters. Cosmic voids are vast spaces between filaments, largest scale structures in the universe, which contain very few or no galaxies. Voids are believed to have been formed by baryon acoustic oscillations in the Big Bang, starting from initially small anisotropies from quantum fluctuations in the early universe. The anisotropies grew larger in scale over time. I don't know how. Guterres void is one of the largest known voids in universe and is referred to as supervoid. Its discovery was reported by Kirchner et al. In 1981. The center of this Guterres void is approximately 700 million light years from Earth. The Guterres void was known to contain 60 galaxies. A normal region of the universe of this size would usually contain many thousands of bright galaxies. Most of the galaxies discovered are usually located near the edges of the void. There are two superclusters in Guterres within 1 billion light years. The nearest one is about 830 million light years away. The second one lies directly behind it at about 1 billion light years. The Guterres superclusters are famous mainly because they lie next to and slightly behind the Guterres void. This void is one of the most famous voids in the universe, mainly because it was one of the first major voids discovered. Picture of the Guterres void, Holeilana, I like this name. In this figure, we can see some spherical, I don't know how to name it, it's shell, Bohr shell, he named it. And inside of this spherical shell, we have both the superclusters, we have Sloan Great Wall, we have CFA Great Wall, and Hercules Complex, all lie within the Bower shell. I don't understand this shell. All these superclasses belong to it, or it's behind of it. It's very difficult to tell it. That's why maybe it's a combination. What is important to me that 60 of these galaxies at the edge of this shell, it belongs maybe to Laniakea or to maybe some other superclusters around. To explain this, phenomenon, I should go back to my macro object shell model. In WC, macrostructures of the world, superclusters, galaxies, extrasolar systems have nuclei made up of universe-created fermions, which are surrounded by shells composed of universe-created particles and ordinary particles. The shells envelop one another like a Russian doll. The lighter a particle, the greater the radius and the mass of its shell. Innermost shells are the smallest and are made up of heaviest particles. Outer shells are larger and consist of lighter particles. A proposed weak interaction of UC particles provides integrity of all shells. Table 1 describes parameters of macro object COS, which are 3D fluid balls which with a very high viscosity and function as solid-state objects. In this table, presented, calculated, and experimental results for some of macro objects. Fermion UCF1 with rest energy 1.3 tera electron volt and the calculated maximum mass of the core based on this UCF1 particle is 1.9 multiplied 10 to the power 30 kilogram. I compared this value with macro object. The macro object is core of the sun. And according to experiments made by astronomers, the core has the mass about 0.7 multiplied with 10 power 30. What is important? It's 2 times less than the maximum energy, maximum mass, but it's because our sun is average. For bigger suns, it will be bigger core. UCF2, it's a 9.6 giga electron volt rest energy of particle. Calculated mass the same, 1.9 multiplied 10 to the power 13. I compared this value with most massive red dwarf Kepler 80 and with its mass 1.4 multiplied 10 to the power 30. You see, even the whole mass of this red dwarf Kepler 80 is a little bit less than the calculated maximum core value. UCF3, 3.7 kilo electron volt rest mass. The core mass, calculated core mass, is 1.2 multiplied 10 to the power 41. What is important, I compared this value with the largest black hole, Ton 618, that the evaluated mass of this black hole is 1.3 multiplied 10 to the power 41. You see how close astronomers observe this so-named largest black hole, the same mass. But what is important, in my view, largest black hole is really the core composed of universe-created particles. They cannot see in optical the telescopes. UC4 with minimum with rest energy 0.2 electrovolts has the maximum calculated mass 4.2 multiplied 10 to the power 49 kilogram. Even today, largest structure, Kipu, I will talk about this structure later, has the evaluated mass 4. Multiplied 10, 47. You see 2 orders of magnitude less than the calculated maximum mass. What does it mean? In the future, astronomers will find superclusters even with larger mass than it is for now. Micro-object bubbles. In WC, cosmic voids are vast spaces between filaments which have no galaxies and contain an only cosmic medium of the world with the energy density equals to two-thirds, but not about 15% of the average matter density of the universe as it is supposed in literature. It's much more. Cosmic bubbles have boundaries between an internal parts of them and surrounding media with a surface energy density sigma zero. We will discuss the physical meaning of sigma zero later. In WC, the observable world is the Hubble bubble with the radius r equals to c tau, where c is a gravitodynamic constant that is identical to the electrodynamic constant c in Maxwell equations, and tau is a cosmological time, and the surface energy density sigma zero that equals hc over a cube, where h is the Planck constant and a is the basic size unit, about 10 to the minus 14 meters. With Nikola Tesla's principle at heart, there is no energy in matter other than that received from the environment. We calculate an energy of observable world. It is in this equation 4 pi r squared sigma zero, and an average energy density of observable world that equals 30 over r, or 3 multiplied q minus 1. That is inversely proportional to r. An energy density unit, r rho 0, equals to rc over a in power 4. The quantity Q, that is a measure of the size R, and HA tau of observable world, is in fact the Dirac large number. T0 is the basic time unit, about 10 to the minus 23 seconds. Q equals R over A, or A tau over T0.
Hey, Vladimir, I can't see these slides. Can you make them bigger?
My goodness. Okay, let me try. I'm sorry. I am sorry. I will put it right now. Hopefully it will work. One sec, one sec.
Just a little caution while you're doing that. I used slide mode to maximize everything last time, but I noticed in the recording that the videos of all our images impacted and cut off the right-hand side of the slide. I didn't see that when I'd minimized them myself. So just a bit of
Yes, it's
caution there.
exactly my point. I increased and now I cannot see the whole. I will try to fix it in the right position, but it's a little bit not enough space for the slide. Can I continue?
Well, I think if
Can you
you
see what I've got down right
can
now?
you
I increased a little bit
can
scale
you
of this slide.
can you remove the what's on the left-hand side, the bar on the left-hand side?
The thumbprints, remove those if you can.
I'm sorry, maybe we can cut us from
Well,
this right side, not
I
left side,
can
because
I
left
can
side
read
I
it
have
better now.
slides.
I can read it better.
But it's not fitting, that's the point. I don't know how to do it.
Full screen, I think, is what you have to do.
I've done it.
But you have
Okay.
to do it on the original in the original window. You have to go back to the original window.
Okay.
Yeah, go back to your
Let me go.
desktop. Go back to your desktop and click on this program and put it in full screen.
I should start everything from the beginning
All
because
right, let's figure that out in the next segment. Just go on.
Okay.
We can. Well, now you're back at the beginning. I couldn't
Yes,
read
I know, but I have to start from the beginning. How I've done it's in an original document, Okay, maybe I will go here. I don't know. I'm very sorry, Harry, that it's confusing right now because you cannot read it, and I have to start everything from the beginning.
But I'm surprised Harry couldn't read it because I can, and possibly others can as well.
Yes, that's why I don't know. I can do it, but it's not fitting. That's why, I've done, and on my screen, it's a full size. I have no problem with it. Oh no.
I'm seeing
I don't know
stuff
what
on
to
the
do.
left. Most of the screen is a light gray color. Your slide is only a small part of the screen in the middle of it. You
Okay,
need to
let
go
me
to your
start from the
PowerPoint
beginning.
app and go full screen,
Okay, let me start everything from the beginning.
or go to slideshow in your PowerPoint app.
Don't save it. Okay, let me start from the beginning, guys.
Okay, you need to go back to your windows, your main windows, and you need to go to the PowerPoint window and do
It's
full
exactly
screen.
what I've done before. Okay, okay.
I think he had his PowerPoint full screen. What he needs to do is do slideshow in PowerPoint. So then the slide takes up the full screen and all that junk around above and below is gone.
But Jim, when I did that last time, the photographs on the right-hand side obscured part of the right-hand side of the slide, cut it off. In the recording anyway.
This way better will be. I know. I suppose because I minimize the column on the left side, but we have a big, column on the right side with our pictures, with our faces. That's why I don't know how to do it. Them smaller. Okay. Can you see
I'm
it, or
sorry
we
I
will
brought
start?
that up.
It's okay.
But one of the issues is that even though we can see it here, when you do the recording, it's much smaller in the recording format, and so you're not going to see it in
Now,
the recording format. Okay, we're ready to go here.
this is the best what I can do right now.
Was Ian saying that the pictures of us was covering up the slide, or the reverse? The slide was covering up our pictures.
The other
No, no,
pictures were
no, the first. But the strange thing, Jim, is I minimized them. I sort of pushed it over and I made them smaller. And it seemed that the pictures were not obscuring the slide. But then in the recording, it did obscure the right-hand side of the slide.
Yes,
Well, we
this
don't
is the
want the
point.
slide.
We have two big pictures.
Because it takes.
all right. Let's go, Vladimir. Let's continue on
I
here.
don't know what to do, how to improve my slides.
Use a larger font when you make the slides. You're using this itsy bitsy teeny weeny font.
Why, guys?
Or you could make it all bold face. That helps with the slide.
Yeah, in general, your slides have too much content in one slide,
I
and
understand,
you
but
really need
it's
to
a
increase the font size and have fewer slides.
Okay, let's continue on here. We're getting
I use a 43-inch computer monitor, so I see everything, like God.
well.
how we can minimize these pictures. How we can minimize here. This is my point.
All
Yeah,
right. We'll
if you
put
could
up
get rid
your
of those pictures, it would solve everything. There may be some way.
Send your mailing address to Rick so he can send us a 42-inch monitors.
I ain't rich.
All right, let's proceed. Vladimir, put up your slides and let's.
So it's Rick
I'm
and
a
not
little bit
Rich.
frustrated.
Okay.
I want to be absolutely sure that you understand not only my English, broken English, but what I wrote in words.
Okay,
That's why,
well,
Well, use bigger fonts.
You don't have to start everything from the beginning. Okay, guys. Okay, I will start everything from the beginning.
Well, you should already be, just go ahead and do share screen.
No, I
You
start. I
scroll-
will
can
start.
scroll down some once you get there to where we were, if you want.
Okay, do your share screen. You're already approved. You don't have to send me a request.
Yeah.
I'm sorry for interrupting this whole thing.
Bigger, but larger. But unfortunately, your
We're
pictures,
not even
shut
seeing
down all
anything. We're not
the.
seeing anything, Vladimir.
Okay, let me try one more time.
Do
I
share
pass this
screen.
slide. Can you see my slides?
No.
Okay.
See, now you know how I felt when Zoom asked me to sign in. You never asked me to sign in before, Zoom. Why are you asking me now?
One sec. Let me do something with my original slideshow. Let's talk 6. Can you see my slide now?
No.
Okay, good.
This is the problem I had last time, and unfortunately, I had to resolve it by logging out and coming in again.
Unfortunately, let's start everything from the beginning. Yeah. Share. Share.
There we go.
But unfortunately, not so much changes I have in my presentation. How
Okay,
to
now
minimize.
scroll down to the.
No, it doesn't want to listen to me. Okay, good. Hi. I can go larger, but unfortunately, there is conflict of interest. The right side and my slides,
All right, we'll move down through the slides. I don't know why it's now you're minimizing it.
Okay, but I cannot read because why we cannot cut our pictures smaller? They're big, that at least 1/4 of my screen, our faces. This is my main point. And before
I
it
don't
was
know
much
anything
smaller.
about how Zoom. I don't know how the Zoom works.
We're back to where we were.
Hide non-video participants. I don't know that works. Under view.
But each participant can actually drag those pictures over to the right-hand side and make them very, very small and make the screen
Yes, it's
larger.
exactly what we need to do, guys.
I've just
Then
done
I
it
will
for
increase
myself.
its size.
I've just done it for myself. So you have to do it yourself. Just hover your cursor over the right-hand side of the slide and you'll see a double line and just move the arrow over to the right-hand side.
Okay, you can start. All right, now we got a 10-minute warning.
Okay, we have 2 hours overall. That's why I hope to be on time in spite of these, troubles right now. Yeah. Sure.
It's more like 1.5 hours, I think.
I don't know what you're doing. We have your presentation is on the screen. It says extrasolar systems. All you have to
Yes,
do
it's
is
exactly my point. What is important, I can see our pictures right now, and I can increase as much. Is it enough for now?
it's fine now. You increase the size.
Yes, because right now I cannot see pictures of our faces. That's why I can do
You
it.
have to go back to the original window. You have to
I've
click
done it
on your
already.
original
It's good.
window and leave Zoom. You have to leave Zoom in order to see the slide.
I can see it right now, and I can move it. I have no
All right,
problem with it.
proceed then.
Yes, okay, let's continue. I'm very sorry for these troubles with Zoom, with pictures, with sizes. Extrasolar system. Extrasolar systems are cosmic bubbles with a boundary between extrasolar systems and interstellar medium that has a surface energy density sigma zero. The vast bubble-like region of space which surrounds the sun, unnamed heliosphere, is continuously inflated by solar jets. The outside radius of the solar bubble equals to 0.12 light years, where m is the mass of the sun. The value of 3 in this equation follows from the ratio for all macro objects of the world. 1/3 of the total mass in the central macro object and 2/3 of the total mass in the structure around it. It is okay. Jerry, thank you so much, but you closed me. It is worth noting that Proxima Centauri is the nearest star to the Earth after the Sun, located 4.25 light years away. It's very important to compare the size of our solar system with the distance between different stars. It's in a good agreement about 40 times less the size of the stars against the distance between them. Galaxies. Milky Way galaxy is the second largest spiral galaxy in the local group after Andromeda galaxy, with its estimated visible stellar disk diameter 185 kilolight years, thickness of thin stellar disk about 2 kilolight years, and mass in the range 1.6 to 3.2 multiplied 242 kilogram. In our view, Milky Way is a disk bubble whose boundary with the intergalactic medium has a surface energy density sigma zero. The disk bubble contains in stellar medium and 100 to 400 billion extrasolar systems. According to WC, mass of Milky Way equals to this equation. We calculate diameter by the following equation from this equation. 2 mass of Milky Way squared, p sigma 0, root squared. And it's 170 to 240 kilolight years. The calculated value of the visible stellar disk diameter is in a good agreement with its estimated value obtained by astronomers. Remember, 185 kilolight years. Considering the average stellar disk diameter 185 kilolight years, we can calculate mass of it 1.92 multiplied 10 to the 42 kilogram. It is in the range of evaluated mass of Milky Way 1.6-3.2. You see very simple equations with sigma zero, and we have a very good agreement with experimentally estimated diameter and mass of Milky Way galaxy. Galaxies formation. concept. The experiment observations of galaxies in the universe show that most of them are disk galaxies. In frames of WC, galaxies emerged due to explosive volcanic rotational fission of our spinning superclusters cores composed of UC particles, UCF1, 2, 3, and 4. As a result of this mechanism, galaxy bubbles created, which have looked like chicken egg at that time. Yolk, spinning liquid core of galaxy with high viscosity composed of UC particles, UCF1, 2, and 3. Yolk contains 1/3 of the total galaxy matter. Albumin, liquid interstellar medium with low viscosity made of UCF3 with dissolved other UC particles. Albumin adds up to 2/3 of the total galaxy matter. Membrane, boundary between interstellar medium and intergalactic medium with surface energy density sigma 0. Extrasolar system emerged due to the explosive volcanic rotational fission of overspinning galaxy core and anti-interstellar medium. As a result, galaxy bubble expands in the plane of the spinning galaxy's core and becomes a disk bubble. Right now to discuss physical meaning of force spatial coordinate.
Okay, we don't have much time left. Does anybody have any questions? I have some questions
let's
about the
answer
last
this
slide.
question because it is a very principal point. We will start the next session. Okay. What are the questions, guys? Because it's always description something, but what is important? I wanted to show you what does it mean bubble. Bubble like you have a bubble in water in some other place, like this one. You have something inside, and it's a different galaxies, so extrasolar system, superclasses, all of them, with some shell, like a shell, and at shell we have an energy density always the same sigma 0. Based on these very simple calculations, you can see the real values for mass of galaxy, for diameter of this galaxy. It's very important value of my model that you can calculate very important astronomical units without very complicated calculations. You can do it by simple equation, what I showed in a previous slides. This is exactly my point, to show how it's easy to work with my model based on a very simple evaluation. Go with sigma 0, have a radius of your bubble, and then you can see how much energy you have inside and what is the diameter of this bubble.
Okay, now here's a question that I'm unclear about. It's not clear I always thought the bubble was empty inside, but you seem to be talking about bubbles with stuff inside.
Yes, I showed you right now. The bubbles have, let me show you. Albumin, liquid interstellar medium. Everybody knows that there is interstellar medium, even in our solar system. That's why it's not, okay.
All right, we got a minute to go. So your idea of a bubble can be a body. It's got stuff inside of it. It's not a void thing, an empty thing.
Yes, it's exactly the right understanding. Void, there is nothing inside. There is no boundary. There is nothing. And it is not, okay, I will talk about this later, what we have right now, this Buddhist voids. It's Buddhist voids. It's not bar. What I mean right now. This is a very important issue. And I will show you later my calculations and you will see what does it mean, Buddhist bubbles. It will be later in the next session. I hope to show you all the results, including new one. It was published only in January 25. That's why my report right now is an answer for this new results, for the maximum mass of some object and all this stuff. That's why, guys, have your patience. Next session, we will start with very principal
All right, let's continue on. Okay, do we have any questions or comments about the last slide that he presented?
My goodness, one more time, these big pictures on the right side. Man. Oh,
I think you said something about 2/3 the energy density in the bubble. 2/3 of what? Of average?
of the total average density, 2/3, 67% of overall matter inside of our observable world is the medium. And our macro objects, they have only 1/3.
Okay.
One sec.
I thought you said 2/3.
That's
Okay,
medium,
I do
1/3
want
macro
to.
objects. Man,
I do
please
want to
listen to
comment.
me carefully.
I do want to comment here. You've introduced this new idea, which I haven't seen before, which is about the chicken and the eggs. The chicken egg. This seems to be new. Is that correct?
No, it was published, and once, a long time ago, I named it. Of course, we should discuss something egg at the beginning. And then because of generation of our planet, we have increasing diameter of it. And of course, it goes down the bubble. You see, it's a flexible bubble. You know what
All
I
right.
mean?
I'm not really clear on how this works, but let's move on to the next slide and we'll talk about this later.
I know, but I don't know how to cut right now these pictures. We have huge pictures. They block my slides. And if I will go down, you will not see it. The main point right now with Zoom, why we have so huge pictures over here. This is my point. Okay, guys, let's continue. Physical meaning of fourth spatial coordinate. According to Ovid, Dewey, and Besson, a fifth dimension might be associated with rest mass via this equation. In WC, there are the following parameters. Gravitational, it has these values in this equation. And surface energy density, as I told you before, it is HC over A cube. We can rewrite this equation in the following way. H over A squared, and then A over C is T0. Can you see that H is divided on surface and T0? That is, in fact, an angular momentum flux density GH. This is a well-known definition of flux density. Angular momentum, because it's H, flux density GH. Observable world, then the total energy of the observable world is equal, as I showed you before, 4 pi r squared sigma 0, 4 pi r squared multiplied on this angular momentum flux density. IH is a total angular momentum flux that is a vector along the fourth spatial coordinate. You see, it's a very important issue. Flux means you have some stream of something. In my case, it's universe-created particles. And this energy, all the energy inside of our bubbles, it's the total flux, momentum flux to this area, to this bubble. That's why E0, what always I showed you guys, right? E observable world, overall energy. It's very important issue. Please ask me the questions right now, because then I will continue. This is a critical point. I never talked about this value, sigma 0. What does it mean? How it looks like? And what is important? Physical meaning of it. It's a total, it's a angular momentum flux density. And whenever you have any area, the total energy inside of this area bubble will be equal to this energy, the angular momentum flux density multiplied on overall surface of this macro object, of this bubble. It is a very, very important issue. Whatever you want to ask me, please ask me, because then I will continue. It will be very simple. But what is important? In my view, we have continuously running flux of these ash particles, because all these particles, they have a spin, so-named spin. They have an angular momentum. And we have not only particles, their mass. We have flux of angular momentum. We need this angular momentum to have a lot of angular momentum before explosive volcanic, fission and so on and so on. That's why it is a very important that we have so-named dark epoch. Dark epoch, it's about 0.4344 billion years. And during this time, we're saturating our world with universe-created particles that they provide not only mass, but rotate angular momentum to this world. It's very important. Everybody will ask, where did you take this angular momentum? We took this angular momentum from the universe, from our nucleus of the world. In a fourth spatial dimension, we have homogeneous, very important issue, homogeneous angular momentum flux density, and then multiplying on surface of any object, you have your total energy. That's why I use the same equations for extrasolar system, for galaxies. Later I will show for superclusters the same story. That's why it is a very important issue, because of homogeneous flux of angular momentum from the fourth dimension, we can calculate easily energy in any bubble, multiply on the surface area of this bubble. Immediately you have your equation, your overall energy inside of this bubble. If you have no questions, the fourth spatial coordinate is associated with all energy of observable world. This is x4, the first coordinate. This is the equations, what is proposed by Wesson and Overdoing. And as a result, we have x4 equals to r, that may be represented as A over Q or C tau. A is a unit size, and tau is a cosmological time. The eternal universe continuously creates, particles with angular momentum. We would like to stress that creation of particles occurs homogeneously in all points of the observable world. It means that for any cosmic bubble with any radius r, it is valid. E cosmic bubble equals 4 pi r squared sigma 0. Nikola Tesla was right. There is no energy in matter other than that received from the environment, from the fourth spatial dimension. He postulated this, point. Oh, yeah, there is no energy because you need environment. And I showed you in this slide that it's coming from the fourth spatial dimension, homogeneously, continuously coming to all the bubbles inside of our world, observable world. What is important? It works for all bubbles, superclusters, galaxies, extrasolar systems, whatever you have, so-named dark matter, Fermi bubbles, and all this stuff. I will show you this later, how it works. Homogeneous saturation of our observable world in any place, for any bubbles inside of it. If you have no questions, let me continue. There are so-named Fermi bubbles. Let's talk about them. It's a very important macro objects in the world, not only in our galaxy. In 2010, gamma-ray observations by Fermi Gamma-Ray Space Telescope revealed previously unknown features in our galaxy that now called the Fermi bubbles. These mysterious structures emerge above and below the center of Milky Way, spanning a total length of about 50 kilolight years. They emit higher energy gamma rays than the rest of the galaxy's disk. A completely unexpected discovery like Fermi bubbles is a special treat. However, scientists know that there are many more surprises waiting to be uncovered by Fermi Gamma Ray Space Telescope. I will talk about the other galaxy and you will see how it works.
Sure.
The outlines of the bubbles are quite sharp, and the bubbles themselves glow in near uniform gamma rays over their colossal surfaces. Gamma ray spectrum at galactic latitude less than 10 degrees without showing any sign of cut-off up to around 1 tera-electron volt remains unconstrained. Years after the discovery of Fermi bubbles, their origin and the nature of the gamma ray emission remain unresolved. 15 years they observe it, there is no real mechanism how it works. Su et al. Identify a gamma ray cocoon feature in the southern and north Fermi bubble, a jet-like feature along the cocoon's axis of symmetry. Both the cocoons and jet-like features have a hard spectrum from 1 to 100 gigaelectron volts. If confirmed, these jets are the first resolved gamma ray jets ever seen. You see, even jets, they found already this high energy gamma rays from these jets, and nobody wants to accept it. They hope that I will confirm them. Conti et al. Report prominent X-ray structures of intermediate scales, hundreds of parsecs, above and below the plane, which appear to connect the galactic center region to the Fermi bubbles. These structures, which they term the galactic center chimneys, constitute exhaust channels through which energy and mass injected by a quasi-continuous train of episodic events at the galactic center and are transported from the central few parsecs to the base of the Fermi bubbles. You see, they've even found that there is some flux of the material, mass, and energy from Milky Way center to these Fermi bubbles. Cooper and Slatier discussed two emission mechanisms in the Fermi bubbles: inverse Compton scattering and annihilating dark matter. In their opinion, the second emission mechanism must be responsible for the bulk of the low energy, low latitude emission. The spectrum and angular distribution of the signal is consistent with the predicted from about 10 gigaelectron volt dark matter particles annihilating to leptons. This component is like the excess gigaelectron volts emission previously reported by Hooper from the galactic center. You see, there is a correlation between the center of Milky Way galaxy, the same gamma rays, and gamma rays in Fermi bubbles. It is worth noting that a similar excess of gamma rays was observed in the central region of the Andromeda galaxy, M31. McDaniel et al. Calculated the expected emission across the electromagnetic spectrum and found that the best fitting models are with the dark matter mass 11 gigaelectron volts. It's very close, 10, 11. WC explanation. WC explains Fermi bubbles the following way. Core of Milky Way is made up of UC particles. UCF1, 1.3 tera-electron volt, UCF2, 9.6 giga-electron volt, and UCF3, 3.67 kilo-electron volts. The second component, UCF2, explains the excess giga-electron volt emission reported by Hooper from the galactic center. Core rotates with surface speed at equator close to the escape velocity between gravitational bursts and over the escape velocity at the moments of gravitational bursts. Bipolar astrophysical jets which are astronomical phenomena well known, where outflows of matter are emitted as an extended beams along the axis of rotation of UC particles are ejected from the rotating core into the galactic halo along the rotation axis of the galaxy. Due to self-annihilation of UCF1, UCF2, the beams are gamma ray jets, remember 100 gigaelectron volts. The prominent X-ray structures on intermediate scales, hundreds of parsecs above and below the plane, named the galactic center chimneys, are the result of the self-annihilation of UCF3 with energies, rest energy 3.7 kiloelectron volts. You see, all these particles, they explain all these, phenomena around Milky Way center to Fermi bubbles. Fermi bubbles are bubbles whose boundary with the intergalactic medium has a surface energy density sigma 0. These bubbles are filled with UC particles, UCF1, UCF2, and UCF3. Weak interaction between UCF3 particles provides integrity of Fermi bubbles. In our model, Fermi bubbles are macro objects with a mass and diameter which are proportional to Q in power 3.2 and diameter in power Q3/4, respectively. According to WC, diameter of Fermi bubbles equals to, I've calculated it according to this equation, where it's 28.76 kilolight years, where L UCF3 is a quantum length of particles UCF3, the main player, because this is a bubble filled with UCF3. The calculated diameter is in a good agreement with the measured size of Fermi bubbles. Some of them showed 25 kilolight years, some of them 32.6 kilolight years. But what is important, I have the calculated value between these values. Mass of Fermi bubbles is calculated with the same equation as usually I've done before. It is about 9.16 multiplied to 10 to the power 40 kilograms. Recall that the mass of Milky Way is about 1.6 to 3.2 multiplied on 10 in power 42 kilograms. You can compare these values and you will see that these bubbles, they have about one order mass less than Milky Way galaxy itself. Big bubbles around Andromeda. In 2016, Pshirkov et al. In the article Evidence of Fermi Bubbles Around M31 performed search for an extended gamma ray halo around the Andromeda galaxy using almost 7 years of Fermi LAT data in the energy range 0.3–100 gigaelectron volts. According to their results, the best fitting halo template corresponds to two 6.5 kiloparsec bubbles symmetrically located perpendicular to the M31 galactic disk, like the Fermi bubbles found around the Milky Way center with a radius about 6 kiloparsec. Can you see it? How close they are? And what is important, these Fermi bubbles, they belong not only to our galaxy, but to Andromeda galaxy, the closest to us. In conclusion, the authors wrote, our findings suggest the possible ubiquity of the Fermi bubble phenomenon in giant spiral galaxies related to their central activities. Future observations, including at energies more than 100 gigaelectron volts, would certainly clarify this issue. Pshirkov et al. Described morphology of Fermi bubbles around M31 without any information about the mechanism of gamma ray emission. It is worth noting that in the most recent catalog of sources from Fermi LAT telescope, fully a third of detected source positions are not known to have a gamma ray emitting object at that location. what could be produced in these gamma rays? You see, if there is no macro object, a visible one, might be it is Fermi bubbles around all the other galaxies. And sort of them, they don't have even the object in there. That's why it's a very good point. Maybe there are Fermi bubbles. WC proposed the mechanism of Fermi bubbles creation and gamma ray emission due to the self-annihilation of UC particles up to 1.3 tera electron volt. In our view, the developed mechanism is valid for all spiral galaxies. No questions about okay, doesn't matter. About, oh my goodness, one more time. Oh no, too small. That's bubbles. This is the very last article published in January 25. By analogy with Fermi bubbles, we can calculate characteristics of cosmic bubbles in conjunction with superclusters. The main difference between galaxies and superclusters is in their outer shells, which composed of particles UCF3 for galaxies and UCF4 for supercluster bubbles. Considering that a Compton length of particle UCF4 is considerably larger than the Compton length of particles UCF3, it's about 20,000 larger. We can calculate a diameter of Booth's bubble and mass of Booth's bubble. Diameter is about half billion light years and mass about 3.2 multiplied on 10 to the 49 kilograms. That is in a good agreement with the calculated value 4.2 in power 10 to the power 49 kilograms I showed you in my table. Can you believe it? This is a huge super bubble, and we have so good correlation between calculated value of mass and the calculated based on the shell of UCF4. It is worth noting that the energy density of the cosmic medium is 2/3 of rho critical. The energy density of superclusters bubbles is 79.5 times larger than the energy density of supervoids, which are in fact examples of cosmic medium in its purest. You see the difference between voids, it's a cosmic medium, the bubbles that they have, even the biggest one, they have 79 times larger energy density than the medium around. And we have our bubbles, with the diameter up to 500 million light years. And the maximum mass, as it was calculated according to the UCF4 particles. Continue. In our view, Booth's bubbles emerge above and below the center of Booth's supercluster. Remember, I showed you the picture, and at this picture, at the center of this sphere, or shell they showed, there are Booth's superclusters spanning a total length of about 1 billion light years. We emphasize that the center of the Booth's bubbles is approximately 700 million light years from the Earth, and there are two superclusters in Booth's bubble within 1 billion light years. The nearest one is about 830 million light years away. The second one lies directly behind it at about 1 billion light years. The center of Booth's bubbles does not coincide with the centers of the Booth's superclusters. Most probably, this structure emerges above and below the center of the first Booth's superclusters. By analogy with Fermi bubbles, we suppose that Booth's bubbles are UC particles cloud made up of particles UCF4, in which particles UCF1, UCF2, and UCF3 self-annihilate and radiate X-rays and gamma rays. There are no galaxies inside of Booter's bubbles. In favor of the existence of Booter's bubbles speaks the fact that the Booter's void is known to contain only 60 galaxies which are located near the edges of the void and, in our view, belong to the neighboring superclusters. To confirm the existence of Booter's bubbles, we should make measurements of high energy X-rays and gamma rays from the Booters. Considering the high concentration of particles UCF4 in Booter's bubbles, it's possible to observe so-named unidentified infrared emission bands, which occur around peaks at 3.3, 6.2, 7.7, 8.6, 11.2, and 12.7 micrometers. In literature, these emissions are observed from circumstellar regions, interstellar mediums, star-forming regions, and extragalactic objects for which the identity of the emitting materials is unknown. Nobody knows where they came from. In WC, we explain this UIB emission based on the self-annihilation of UC particles UCF4 and BUCF4 with a rest energy about 0.38 electron volts. To the best of our knowledge, WC is the only cosmological model in existence that is consistent with UIB emission phenomenon. It is a very important. It's better for astronomers right now to go with these wavelengths to watch for them, because all the galaxies, they have this UIB phenomenon, but nobody cannot understand it. Nobody can explain it because there is no material to radiate all these near-infrared wavelengths. Superclusters were close to finish. In 2014, Tully et al. In the article The Laniakea Supercluster of Galaxy described the Laniakea Supercluster, a collection of around 100,000 nearby galaxies, including Milky Way. It was known as one of the largest superclusters with estimated binding mass about 10 to the power 17 mass of the Sun. Laniakea supercluster stretches over 500 million light years that corresponds to the calculated diameter of single bubble made up of UCF4. We emphasize that about 100,000 nearby galaxies are moving around center of Laniakea supercluster. All these galaxies did not start their movement from the initial singularity. The neighboring superclusters have the same structures. You know, Tully, he's a great astronomer. He observed, he discovered this Laniakea supercluster, but he is orthodox. He tried to explain this supercluster in frames of Big Bang model. It doesn't work, but he's trying to explain all his discoveries in frames of Big Bang model. In 2025, Boehringer et al. In the article Unveiling the Largest Structures in the Nearby Universe, Discovery of the T2 supercluster, provide first all-sky assessment of the largest structures at distances between 130 and 250 megaparsec, and discuss their observational consequences using X-rays in the 0.1 to 2.4 kiloelectron volt energy band galaxy clusters to map the matter density distribution. It is very important to show that they observed these superclusters by X-rays, not by redshift and all this stuff as it was before. By X-rays, it doesn't depend on Z. Among the 5 most prominent superclusters found, the largest has a length longer than 400 megaparsec with an estimated mass of about 2 multiplied 10 to the power 17 mass of the sun. This entity, which we named Q, is the largest cosmic structure discovered today. In you see, the observable world presents a patchwork quilt of different luminous superclusters, more than 1,000, which emerged in various places in the world at different cosmological times. According to WC, we expect an observation even larger superclusters in the future, because you have at least 2 orders of magnitude to go further with the mass of superclusters. They saw only a few superclusters in a nearby observable world, but there are so many other superclusters around. At last, I will read conclusion. In my article published in 2024, I provided short summary of experimental observations of Booth's void and superclusters, introduced notions cosmic voids and cosmic bubbles, elaborated a mathematical framework for different types of cosmic bubbles, Hubble spherical bubble for the observable world, disk bubbles for galaxies, spherical bubbles for extrasolar systems, Fermi bubbles for galaxies and superclusters, made the conclusion that the Booths are Fermi bubbles and suggested experiments to prove it. WC proposed the mechanism of Fermi bubbles creation and gamma rays emission due to self-annihilation of UC particles up to 1.3 tera-electron volt. In our view, the developed mechanism is valid for all spiral galaxies. WC confirms the source of energy in the observable world postulated by Nikola Tesla. There is no energy in matter other than the received from the environment, from the force WC. Thank you so much for your attention, for your patience with my slides, with all the troubles with Zoom and all this stuff. I hope to have a lot of questions from you, and I will try to answer all of them. Thank you so much.
Okay, we got 3 minutes. Thank you for your presentation there, Vladimir. Does anybody have any brief comments to make or suggestions as to questions that Vladimir can answer in the next session? No take.
Everybody tired, they don't have questions, maybe too much.
I think there's been tons and tons of comments, so I'm surprised there's such silence.
It seems to me that Vlad could make a presentation that is simpler and shorter and deals with his theory more so than the details of other people's work that he uses to include in his theory. A lot of us here are unclear exactly what the world universe model really stands for, and we just have a vague understanding of it.
Let me give you a comment. First of all, I showed all the experimental results from astronomers. I refer to all of them without any doubts, because I am not astronomer. I'm trying to explain their results. The second point, WC belongs to me only. I didn't use any ideas from anybody else existent right now. I mean, different models and so on and so on. I used only the main ideas of Dirac in 1937. The first idea was gravitational constant is not a constant, it depends on time. And the second point, continuous creation of matter. And the third one, Nikola Tesla, that we have the energy from the environment in all our observable world.
Well,
Three very important, ideas. I use them and I refer to them many times, including today.
well, I was referring to actually you making a different presentation, a simpler one, one that doesn't delve into all of the confirmations, you might say, that of your model. You know what I mean? Like to help us understand the model better without all of the extra detail, all the flotsam and jetsam.
Let me tell you, I
30
last year,
seconds.
1 second. Last year, I've done 8 presentations at EON conferences. That's why, you can take a look how many results I confirmed by my model.
Well,
Even
why don't you do one here?
With Harry, I've done already 6 talks plus. Thank you so much. Let me finish my answer for the previous comment. That's why in my model, I use only 3 very important ideas. Nobody used these ideas at all. That's why there is no influence on my model of anybody else. The second very important comment is very simple. Let me summarize results of this presentation. First of all, I gave all the experimental results about all kinds of cosmic bubbles, including superclusters, galaxies, extrasolar systems, and all this stuff. The second point, I showed that in frames of my model, I can easily calculate diameters, size, and mass of all these kind of bubbles. That's why it seems to you that it's too much details. No, the main idea very simple. There is a sigma zero, and whenever you will calculate on 4 pi r squared, any r squared, you will have the overall energy. And this rule, this law, a new law, works for all bubbles. Then in this presentation, the very first time, I showed you what does it mean sigma zero. It is angular momentum flux energy flux density. And if you will multiply on any surface 4 pi r squared, you have overall energy inside of this bubble. Simple like this. And then I spoke about superclusters. One of them, Laniakea supercluster. Another one, they reported about these new superclusters with twice larger mass. Only in January 25. That's it. That's why it is not so complicated, guys. You overcomplicated my details. Take a look on the main ideas I tried to put today in my presentation.
Of Vladimir. Well, I have to admit, I often have trouble following your presentations, but I mean, there's so many facts and complex observations and such that I can tell you go to a lot of trouble organizing it all. It's just that I can't tell how it relates with your theory or how the WC accounts for it. Much of your technical observations and facts and such.
Jerry, right now I summarize the idea. There is no so much equations. There are no so much details. There is only one equation. Energy equals to 4 pi pi r squared. That's it, sigma zero. And the main point in this presentation only the physical meaning of this sigma zero parameter. I used it all the time, but today I showed you what does it mean. It means the total energy equals to total flux, and that's it, of angular momentum flux. You see, many times I told you, we're saturating our observable world with some flux of particles from the fourth dimension. And I showed you today, it's not only mass or energy density of these particles. They supply us with rotational or angular momentum. Because for the validity of my model, you must have angular momentum. And you have all the time saturated with angular momentum. That's it. Guys, you overcomplicate it. Maybe, I don't know. I try to give you shorter details of my model. But for my model, there is only this equation. That's it, guys. Nothing else.
Well,
Well,
I
That's
that's
why
wish
you
you would
told me
present
it's
your
so
model and
complicated.
your
But
model
there is
alone.
only this equation. That's it.
I wish you
Sorry,
would
James.
present your model for the first time and the model alone so that we could see what it is. Like, for example, you say that these particles that you postulate have angular momentum. Do they physically spin, or is that just a mathematical idea?
I have no idea about micro objects. What does it spin? Maybe you know. I don't know. What does it mean? I know that together with angular, with these particles, we saturating our observable world with angular momentum. That's it. What for me is important. I
So your
don't know
model does
any
not have an
details of the
explanation for
particles.
that.
Huh? I'm sorry.
Well, I think what we need to have is a list of actually what the model consists of. You said it's one equation, or maybe it's two or three or whatever. That would be fine. And what it does not explain, because you just said one thing it does not explain, where the postulated particles get their angular momentum. I think that kind of a presentation would be great. And if you double the size of the font, that would also help. And it could be very short because basically you're saying there's only a few basic ideas in the model.
Let me remind you, thank you so much. It's a very good comment. That the second my presentation at Ian's meeting was dark matter particles. The whole 1 hour, I explained all the source of these particles, what their masses or rest energies, and all this stuff. That's why even this one component about particles, I talked about for 1 hour. What is important? The same, presentation I've done at our Zoom meeting too. Guys, it seems to me that all the time you forgot everything what I taught before. And that's it. And you start everything from the beginning. Please remind something yourself. Please read my presentation I sent to Harry, the copy of today's presentation, and prepare your questions before we will start our meeting. That's why you guys, please remember something, because it's impossible me to open the whole base of the physics, because cosmology is a new physics, and trying to explain you during very one short, maybe 20 minutes talk about the all ideas I put inside of this model. I published already 39 particles about this WC model. The last one will be published in March this year. That's why I don't know what to do, guys. I've done so much for
Well,
24 years
Vlad,
that I
judging
don't
by
know
your
how to present
presentation,
to you. I'm sorry?
judging by your presentations, you've never actually presented the bare bones version of your model. And all, like a lot of calculations, a lot of historical references, a lot of predictions. But all of those things, the calculations, predictions, historical references, that's not your model. The model is, a basic, 1, 2, 3 basic postulates or assumptions, maybe a few equations, a few definitions, period, end of story. No calculations. Except what is
Jim,
absolutely essential to present your postulates and assumptions. That
let me
presentation,
refer to
I
you.
have never heard from you. And I'm beginning to think that you don't have such a model, that you simply don't have it, or you're not a theoretical physicist and you don't know how to do that, which is okay. Maybe someone else has to do it for you.
I'm very sorry, nobody can do it. Sorry. Let me remind you, first of all, You're not looking for our works together with Harry. Harry gave a very good proposal the last year to put 3 pages only explanation of the model. Did you see? Jim, you don't have any respect to me and to Harry. And it was published last year. 3 pages. Why you didn't see it?
I don't know why I didn't see it. I would like to
I'm
see it.
sorry. I referred to it many times. It was a very great proposal of Harry. We changed even the name of my model. Now it's a World Universe Cosmology because of him. It was a very good partnership with him. Please, I forward to you, all of you guys, these 3 pages, very compact article, and you will see what you're asking today. Guys, I'm very frustrated, with what? We
Okay,
have how many? I'm sorry, Harry.
all right.
I'm
I think the issue here is that Jim wants you to explain what the model is every time you give a presentation because he can't remember what it was that you said.
He cannot remember. He cannot read even. Because Harry, we done
I,
this a great job.
I understand Jim's comment. I think the real issue with this presentation today is this business of cosmic bubbles kind of confused me. I didn't really understand. I thought you were going to be talking about something different than what you were talking about. So that kind of,
I'm sorry.
confused
I
me.
gave the definition. What does it mean, cosmic bubble? I gave a definition today. What else you need? I even gave you the example. You have your liquid water and bubbles, air bubbles inside of it. What's wrong with us? We don't understand this, once some bubble inside of the medium.
Okay,
Air bubble
I think
in air, in
the
water.
issue here is that there's a lack of visual aids. And I made this comment to you before, which is that you don't have many visual aids. And I think that's one of the main issues, is that there needs to be visual aids. Jim can't understand your model because he needs a visual aid. He needs a picture, simple picture that explains to him what your model is, because he can't imagine a 4-dimensional space and so he needs a picture.
What can I do about 4th dimension?
Right. Well, he needs a picture, and you don't have any pictures in this presentation about what a cosmic bubble is. And there's different cosmic bubbles. You need to have some kind of, at the beginning, you need to say these are the different kinds of bubbles I'm talking about, and you need visual aids. I think that's one of the main issues. Need to have some kind of picture. A lot of people aren't verbal.
Another issue is that this 3 little pages that we're talking about should list specifically the strengths and weaknesses. For example, just a few minutes ago, Vlad was pointing out that his model does not explain the origin of the angular momentum in the little particles that are postulated, so that there should be a little list of what is not accounted for or where the model is incomplete. And I would suggest that he look for a theory of everything that is complete and correct, but at least in presenting his model, if he were to do so, that what it explains is one list, but what it does not explain should be another list, so that investigators will know this is the frontier that we need to look in the future, because these are the things that are not explained.
Well, I think they can figure that out for themselves.
Harry, let me answer this.
I think that the real issue here is there needs to be a visual aids. There needs to be diagrams and visualization. And I think that's...
next time, maybe I will show you the water and air bubble inside of it. It's exactly my model. It's so complicated. Without picture, we cannot do it. Let me comment the the question of Jim. Jim, you are great guys. You have your theory explaining everything, beginning from spin to the cosmology. Cosmology. I don't like it. I'm very sorry. It's everything explained in your model. Wrong. I will tell you why. Because I am in business of classical physics. Classical physics. It's totally different story. And I'm talking about energy density on surface. It's a classical notion. This classical notion I showed, it's a flux of angular momentum. But this flux belongs to ensemble of particles. It is not spin of each. No, it's and like I showed you already, these experiments with one photon, we can see the particle, and we can see the interference pattern when you have ensemble of particles. The same story in here. Don't mix your theory, your micro mirror with macro mirror, with macro objects, with classical physics. That's why I will never answer any questions. It's your business to explain what does it mean spin, what does it mean, all the parameters of micro objects, of quantum physics. I am classical physicist. I'm working with classical physics. That's why in my explanation, always I have in mind, and I hope in your mind too, ensemble of particles. Don't ask me these questions. What you must answer. You must answer. What does it mean spin? And I will try to understand you. What will be your picture even about how spin does work? I don't know. Nobody maybe knows. Maybe you know. Please, next time explain me. What do you mean spin? I don't know. I know that the ensemble of particles bring to us this, angular momentum. Let me give the good example. We have wire. Inside of the wire or at some other places, we have electrical current. But electrical current is an ensemble of electrons moving in wire. The same story in here. We have flux of this ensemble of particles from the fourth spatial dimension. And that's why all these micro parameters, forget asking me, ask yourself. And will be very good if the next time you will answer all these questions about microphysics, this quantum physics, all this spinning and all this stuff. I will be more than happy to hear you and to ask these questions, what I am ready to ask you now.
Fair enough.
Okay, next time, make your report and try to explain your theory, because theory of everything, I don't believe it. It's totally different story. One particle, ensemble of particles. And you're trying to combine all these two different branches of physics. Okay, you're great guys. I'm not. I'm sorry.
Well, one little thing which might help a bit is in your introduction, in your introductory lectures, you actually contrasted your own ideas and your own model with the mainstream idea. I mean, the whole WUC and the the universe created particles and the period of darkness and all that sort of thing. Well, when you're dealing with specific things like, say, cosmic bubbles, it might help us a bit if you included a reference to uh, your ideas as against the mainstream and how they contrast and how they are different and maybe even similar in some respects.
I'll try to, in my presentation, to do it. Let me. Even I gave you guys the very first table to show what is important for this, particular presentation. Only rest energies of all these universe created particles, because different particles are responsible for different size and mass of our cosmic bubbles. You see, that's it, what we need really for this presentation. Simple like this. That's why, I try to do. First of all, I gave you all these, details, experimental observations, astronomical observations, and then I showed you how my model works with these experimental results. What is important? My theory, it is not theoretical, high quality, high level. No, it is a simple classical model. Simple like this. All the equations existed. I didn't invent any other equation as it is. What I told all you guys, cosmological parameters depends on time. Dirac told in 1937, oh my goodness, it's close to 100 years ago. And I now use this approach that's simple like this, but physical laws stay the same. I don't want to invent new physics. No, physical laws because they depend on the parameters of the cosmic medium. That's it. They don't depend on a macro object, nothing. And I showed you many times that these physical laws depends on cosmic medium that is homogeneous, isotropic, and all this stuff. But please only consider take into account that the parameters depends on time. That's it. All the rest is same. You don't need to invent any new physics. It's only upgrade of the existing physical laws with idea of Dirac about 100 years ago. The second very important point, all my model I based on experimental results only. I always know this rule. If you want to propose some model, theoretical model, you must explain all the experimental observations. It's exactly what I am doing each presentation. Because even you have one result, you cannot explain in frames of Big Bang model. It is wrong, absolutely wrong. To prove that something wrong, there is only one experimental result, and that's it, you killed it. To confirm that your model works, you must explain everything, all the experimental observations, discoveries in our physics. It's exactly what I'm doing. Even today, I reported about this Buddhist bubble. Today they published this paper in 2025 January, 2 months ago. And immediately my response, guys, it's not your bubble. No, it is superclusters Fermi bubbles. That's it. And you can see it like a white wine because you are looking with telescope. We cannot see even our Fermi bubbles in Milky Way without gamma telescope. It was accidentally discovered in 2010. How many results we have got before? And suddenly we saw elephant close to our Milky Way center, guys. And the same story I proposed even to prove that this Buddhist bubble, how to confirm? Go with gamma radiation and look at. If you will see gamma radiation, X-ray radiation, then you can do bubble like Fermi bubble we have around our Milky Way. If not, it's a void, but
All
it
right,
is not
Vladimir.
power. Yes.
Vladimir, let me interrupt here. I think the issue is, well, I think there's a lot of problems with this presentation. One of the issues is that you try to condense. There's too much information, and you're trying to pack too much discussion into a short period of time, and people just don't understand what it is that you're talking about. So you've got these observations that you're talking about. Boötes bubble. You could probably need some kind of picture. You need some kind of. It's very difficult for me to understand what you're talking about. And I'm an amateur astronomer, and I know about this stuff. So people in this presentation don't even know anything about astronomy, or very little. And I don't see how they can understand what you're talking about. So I think the issue is you go from talking about observations in a very technical sense, which is you refer to these papers. Okay, it would be better if you had brought in some pictures from these presentations, from these papers that illustrate what you're talking about. And I think that's important to basically give people an understanding of what these things are, these bubble things that you're talking about. I don't think people even understand what it is that you're talking about. Am I wrong
Plus,
on
I
this?
think
Can anybody
plus,
chime in and tell me that you understand exactly what he means by the Bote's bubble?
well, I have a
I showed you
comment
the
there. I
example,
think
egg.
Vlad
I
needs to.
compared my bubbles with egg. Do you know what does it mean, egg? I don't know mine. How more simply to explain you? Egg model. I explained you egg model in frames of my, Fermi bubbles and all this stuff. Guys, I don't know how simply to give you this,
All right, let me
ideas about.
stop you. Does anybody understand what a Fermi bubble is? I think I do, but does anybody else on here know what a Fermi bubble is that he's talking about? Rick, do you know
I
what he's
do.
talking
I think I know what a Fermi bubble is. If we look at a comet and we see the cometary glow that encompasses our comets, you'll find that that glow is as large as the sun when it comes in and activates as a comet. These jets of matter that are being shot out of the central cores of galaxies are electrons, X-rays, gamma rays, photons. They're all high energy particles being shot out at relativistic speeds. And that glow are that Fermi bubble is that glow of that matter being motioned out of the central axis of the galaxies. That's what I think a Fermi bubble is. That same kind of cometary glow.
It's at gamma rays, I think is what he's talking about.
Gamma rays
What
are
I'm talking,
photons.
it's experimental results, guys. You're talking
Gamma
about some electrons, but it's a gamma quants up to 1 tera electron volt. What are you talking about?
gamma rays are high energy photons that
Yeah,
penetrate
Yes,
through
how
what
many
everything.
about your
people
electrons?
here
What you're talking about?
how many people here actually understand what he means when he says something in giga electron volts? How
Yes.
many people
Yeah,
understand what that means? Not many, I would think.
I think
Hopeless
it's
for me to explain you anything, guys. I'm very sorry. I'm totally frustrated, and maybe I will stop my talking to you because there is no need. There is no something in your minds after each talk. All the time the same story, guys. I'm so sorry.
Okay,
I've
well,
done at least 15,
you're getting
16.
overly pessimistic, Vladimir. I think
I'm pessimistic now. I'm
the
pessimistic
point is
because
that what
all the
I'm
same
trying to
people
say,
and
the
there is
point of
no
what I'm
understanding
trying
at
to
all.
say, what I'm trying to say is you're putting too much information too quickly in front of people, and they can't really comprehend all these things that you're talking about that you're putting in front of them all at once.
Yes,
You
I think
understand what I'm saying?
giga.
an example of this is a 5 or 10 or 20-second question gets a 5-minute response. In other words, Vlad, you need to be able to focus. Harry just asked Rick a question in about 20 seconds, and Rick answered the question in less than a minute. He didn't ramble on for 5-10 minutes, and so you have to learn to focus on what the question is and what the main point is that you want to state as the answer to that question, and then stop talking at that point. If that
Jim,
one main point in your response is not enough, the person who asked the question will come back with more, and then you can respond again, hopefully very briefly. But these 2 hours worth of 3 40-minute sessions get eaten up by the speaker, in this case Vlad, speaking 5-10 minutes at a time in answer to a 20-second or 5-second question. I mean, we get nowhere.
I'm sorry, Jim. Rick, he answered the question with electrons, with all this stuff. He's absolutely wrong because he doesn't know even what does it mean Fermi bubbles. gamma rays. It's not electrons, it's a gamma rays with energy, tera-electron volt. And he answered the question absolutely wrong. It's so simple during 1 minute to answer some questions in the wrong way. Simple like this. You don't know anything about it. You're ready to answer.
Gamma rays are
Vlad,
photons. Gamma rays are
Vlad,
photons, not electrons.
Well, okay, let's
I disagree with the
let's
concept of photons.
But you see,
personally.
Vlad could come back with that answer, a response to what Rick said, precisely because Rick didn't talk for 5 or 10 minutes to eat up all the time. You see the point I'm stating here?
Okay, we got 10 minutes here to go. I understand. Yeah, there's a difference of opinion about what a Fermi bubble is. So there we go.
I think
Nobody knows what
I
does
think
it
it's
mean, Fermi
important to-
bubble. At least take a look in a Wikipedia and see what does it mean, the Fermi bubble. This is the
I think
point.
it's
People, they
it's
know
important.
nothing about it,
Yeah.
and they have already answers.
Well, does Vladimir say that what Rick said was accurate or not? That would be an interesting response.
Well, he said it was not accurate. He said it was totally wrong. So that's the thing, is that, when Vladimir introduces a new concept, it can't be just constantly talking. This is not the format of this group. The format of this group is supposed to be a conversation back and forth. That's why we all have the ability to speak. But we need to maybe, as Vladimir is speaking, you can just stop and say, does that make sense? And we can discuss that particular part of it instead of going on and on and on and building information upon information that we don't understand the basis of yet. It's not really, a lecture format here. It shouldn't be. I don't think that's the purpose of this kind of discussion group.
You're absolutely right.
So I think that's part of what's going on. We do the same thing on Saturday. It's a lecture, and then you discuss the lecture afterwards. But I don't think this Sunday meeting should be run that way.
When to talk, I try to follow your idea. And unfortunately, Jim was the very first who started to ask the question. I will answer later. You see? Oh, and then he blamed on me that I didn't talk about it. I cannot, after the first slide, to tell me what I will tell you in slide number 15. You see, I try to do it, guys. I'm trying to get you. You will understand the principal points of my model. Always I'm trying to share with you ideas, what I put in, and some experimental results obtained by some other great guys, to explain their results in a new way.
Vlad, with all due respect, what Cornelius is saying is there should be no slide 15. There's too much material there. You need to focus.
I think, Harry, you brought it up. I mean, initially you were working with Vlad to try to help solidify his concepts and that. So I would guess from that you have a fairly good image of what his theory is and what his views are. And perhaps you could kind of present a synopsis sometime of what that is.
I already did that.
I'm just saying, do it in this forum, and Vlad could then, speak to that and clarify that in more detail if he felt that you didn't express his opinions right. Maybe it needs to be, secondhand information to see how well it's understood, and if it needs clarification from your standpoint, then Vlad could clarify that at the time.
A little reinforcement couldn't hurt.
One sec, let me tell you, let me talk. Cornelius, you gave very great idea. The best guy who knows everything is Harry. He enforced me to do so much different the last year. It was his idea of these 3 pages, article, paper, I don't know how to name it, doesn't matter. And it's everything inside of it, and he agrees with it. He's a co-author of this, paper. What is my proposal? You're absolutely right. Let's ask Harry next time to take this 3 pages article, our mutual article, and in his words, to explain you guys what does it mean. It is a great idea because the best promoter of my
Well,
ideas,
hold on,
Harry.
hold on, hold on, hold on.
Harry, only you can do
I'm
it.
too confused to even want to do that now. I'm
Only you
pretty
can do it.
confused.
It's proposal of Cornelius.
So,
I like it very much.
no, but I don't. I'm too confused,
I like
and
it.
this presentation has confused me completely, and I'm completely I'm completely confused as to what it is that you're talking about, because I don't understand what you're trying to accomplish in this presentation, and I don't know that people can really say what a cosmic bubble is or what it is that you're talking about. And there needs to be visual aids, Vladimir. You need to have pictures. You need to have visual aids, and that's you need to work on pictures. You need to work on diagrams. You need to show how your model works in diagrams and pictures. And
Well, how about
that's the main problem
Harry,
here.
I'm sorry. Harry, you have these 3 pages article. There is no cosmic bubbles at all. Please concentrate on our mutual article, 3 pages, and do whatever you will propose for me to do next time. It will be very good example of the right presentation,
All right.
because maybe I'm absolutely wrong with my form of presentation. Please do it. You are the best.
Yeah, let's
And
cover
only
what you
you
do
can
understand,
initiate all
Harry.
the people around about this, my model.
Yeah, let's
I
cover
don't
what
really
you do
think I
understand and
understand
not the Fermi
his
bubble.
model much anymore. My point is that I don't really want to do that because I don't really understand what he's talking about anymore, particularly after this presentation.
Okay.
Well,
It sounds like Einstein was a simple concept and it grew into something that nobody understood anymore.
Yeah. Well, I think
the problem is
I want
that if
I
you
want
have
Vladimir to do diagrams. I want him to show me some diagrams, and that's the problem. It's all just talk and words on paper. It needs to be pictures, and I can't understand what he's talking about from these words and equations, and there are no pictures. I can't visualize these bubbles. I can't understand these UCF particles. I don't understand what they are. I don't understand how they relate to each other. You need to have some diagrams that show these relations in these things. You need visual aids. And I've been saying this for a long, long time now. You need visual aids. Without visual aids, people just can't visualize what you're talking about.
plus things tend to change over
Right, you're right,
time.
Harry. Thank you so
had,
much. It's a very good recommendation.
We had UCPs and now we have UCFs. But in the future, for anybody presenting here, I found that if you have more than 4 or 5 slides, that's the time to stop.
Well, I agree. There's too much information.
How many slides you had in your report?
Well, my last presentation here, I think I used about 3 or 4 slides, 2 or 3.
No, I mean the last your session was 1 hour. How many slides you had?
In
you
the
contradict to yourself.
presentation, yes, that was a 1-hour presentation. But if you're going to go more than 3 or 4 or 5 slides, you're leaving no time for discussion.
2
And
hours.
what we hear
is the end here.
Not 1 hour, 2 hours. What you talking
All right, we're
about?
coming to the end. What do people think about changing back to 10 o'clock at standard time for the United States? Is that a problem for anybody?
Yeah, it should be 1/2 hour after the New York Stock Exchange opens, so that you can definitely know what time it is, no matter where you're in the world.
I mean, it is USA centric, so I think we can accept that. And there's only a period of about 3 weeks between the time that the USA changes and Western Europe, say, changes, that we have to adjust. And then it's back to normal. There are 5 hours between us. So I'm happy sticking with US centric time, which is the actual time, Eastern Standard Time.
We'll go from that.
All right, I'm going to go with Eastern Standard Time for the
How you
next
doing?
Sunday, and then we'll consider switching because I'm not really sure how to do the switch yet in terms of Zoom. Zoom has got me baffled as to how to make this change. So
But
I have
see,
to figure
Harry,
that out.
Zoom automatically informs us, allowing for any change which occurs in another country. So, in other words,
I
my Zoom
realize
tells
that, but if I change the primary time, I'm talking about I have to change the primary time.
yeah, but I mean, I don't know if you did anything. My Zoom